Exercise 9.1 Maths NCERT, all questions solved. In question 1, an artist is climbing on a rope which is 20 meters long, which is tight at the pole. We have to find the height of the pole and making an angle 30 degree. Because opposite side and hypotenuse is given, so apply sine theta, opposite side upon this is hypotenuse, sine 30 AB upon AC, sine 31 upon 2, AB is h upon 20, therefore length of the height of the pole is 10 meter. In question 2, this is the height of the tree. Due to storm, broken part touches the ground and making an angle 30 degree, and which is 8 meter away from the foot of the tree. In this case, hypotenuse we have to find the broken part of the tree and AB the remaining part of the tree. Therefore cos 30, apply cos 30, we will get AC equal to 16 upon root 3. To find hypotenuse, apply tan 30, that is AB equal to 8 upon root 3. Then height of the tree will be broken part of the tree, remaining part of the tree. The answer is 8 root 3 meter. In question number 3, there are two slides. One is 1.5 meter, which is for younger children's, and this is for 3 meter height of elder children, which makes 60 degree, and smaller children 30 degree. We have to find the length of slide in each case. Because opposite side is given, we have to find hypotenuse, that is length of slide. So apply formula sine theta. And sine 30, AC equal to root 3 meter and PR equal to 2 root 3 meter. In question 4, from the point of tower, from the point on the ground, the angle of elevation is 30 degree and the point is 30 meter away from the tower. We have to find the height of the tower. No role of hypotenuse, so apply tan theta equal to opposite side upon adjacent side. Apply then tan 30, then you can solve. 10 root 3 meter is the answer. In question 5, a kite is flying at a height of 60 meter above the ground and making an angle 60 degree. We have to find the length of the string. Opposite side is given. Length of the string we have to find. No role of adjacent side. Then apply sine theta equal to then sine 60. After solving, the answer is 40 root 3 meter. In question 6, 1.5 meter tall boy is standing and from his eyes the angle of elevation to the top of the building is 30 degree to the 30 degree, and after moving toward the building the angle changes to 60 degree. Now this is total height of the building is 30 meter, therefore this height will remain 28.5 meter. In triangle ABE, apply tan theta, no role of hypotenuse, so apply tan theta. So x2 equal to 28.5 root 3, and triangle ABE, tan theta tan 60 equal to, then x1 equal to 28.5 root 3. But we have to find the distance traveled. This distance traveled, this one, x2 minus x1 we have to calculate. Subtract x1 from the x2. The answer is, after simplification, 19 root 3 is the answer. In question number 5, the angle of elevation from a point on the ground to the top of the tower, which is fixed on 20 meter high building, is found to be 60 degree, and angle of elevation from this point to the top of the building is 45 degree. Length of the building is 20 meter. In both cases diagonals are not required, then apply tan theta in triangle ACB and in triangle BCD. Tan theta equal to opposite side upon adjacent side, tan 60, put the value in tan 45. On equating the value of x, after solving, h equal to 20 root 3 minus 1. In question number 8, 1.6 meter statue is fixed on the pedestal. Find the height of the pedestal. The angle of elevation from this point to the top of the statue is 60 degree, and the angle of elevation from this point to the bottom of the statue is 45 degree. Again, no use of diagonals, apply tan theta in both triangles. Then on equating the value of x, h equal to, we shall get 1.6 root 3 plus 1, that is on simplification, h equal to 0.8. In question number 9, from the top of a building, the angle of elevation from the foot of the tower to the foot top of the building is 30 degree, and from the foot of the building to the top of the tower is 30 degree. No use of diagonals, again apply tan theta in both the triangles. After simplification, x equal to, this is also x equal to, on equating the value of x, h equal to 16 2 upon 3 meter is the answer. In question 10, there are two equal poles of equal heights making an angle 30 degree and 60 degree. The point between the road, which is 80 meter wide. Now tan 30 degree and tan 60 degree because no role of diagonals, so apply tan theta. X2 and x1 we have calculated, but x2 plus x1 is given 80. By putting the values of x2 and x1 after solving, the value of h is 20 root 3 meter. Then put the value of h in equation x2 and equation x1. We can find x1 and x2. In question number 11, a TV tower stands on a bank and this is the bank, other bank. Angles from this point to the top of the tower is 30 degree, and from another point the angle is 60 degree. Again, suppose this is x1 and this distance is x2. Let the height of the TV tower is x. Again, no use of diagonals. Apply tan theta. Calculate x2 and x1, but x2 minus x1 equal to 20. After solving, h equal to 10 root 3. Then width of the river, by putting the value of x1, h upon root 3, that is 10 meter. In question 12, from a 7 meter tall building, the angle of elevation to the top of the tower is 60 degree and angle of depression from its foot is 45 degree. That are alternate angle. This is 45 degree. In this case, diagonals not equal. Apply tan theta in this triangle and in this triangle. In triangle AED, tan theta tan 60 equal to AE upon DE. AE upon DE. Similarly, tan 45 CD upon BC. CD upon BC. X equal to 7 and x equal to this. On equating the value, this is the value of h. In question number 13, 70 meter lighthouse in the sea, seeing two ships making 30 degree and 45 degree, diagonals not equal. Apply tan theta. X2 equal to and x1 equal to. We have to find the distance between two ships, x2 minus x1. That is the answer. At instant, a boy is flying a kite at a height of 30 meter, at a height of 88.2 meter. But the boy's height is 1.2 meter. Angle of elevation from his eye. Therefore, this distance will become 87 meter. Similarly, this is 87 meter. And after some time, the balloon move away. After losing his string, the angle becomes 60, changes to 30 degree. Now in both triangles, apply tan theta. Tan 60 opposite side EC and DC, in tan 30 AB and BD. In both cases, x1 87 upon root 3 and 87 root 3. Distance travelled x2 minus x1, which is after simplification, after rationalization, 58 root 3. Question 15. A national highway routes to the tower and a car is approaching to the tower. When its angle is 30 degree, in 6 seconds the angle changes to 60 degree. We have to find the distance from C to B. Now in triangle ABD, tan theta equal to opposite side upon adjacent side and tan 30 AB upon BD, x2 equal to root 3h. Similarly, in tan 60, h upon x1, tan 60 root 3 upon 1, x1 equal to h upon root 3, but x distance travelled in 6 seconds, that is x2 minus x1, that is 2h upon root 3. As we know that speed equal to distance travelled in 1 second mean distance divided by time. Distance divided by time, and distance divided by time is known as speed. That is 2h upon root 3 into 1 upon 6 h upon root 3. Now time taken by car to travel foot of the tower. Then distance divided by speed. Distance is h upon root 3 divided by speed. The answer is 3 seconds. Then total time 6 seconds plus 3 seconds equal to 9 seconds. Please like, subscribe.